Hi, this is Mrs. LaBarbera. This is AP Physics Chapter 7. Today, let's talk about an energy graph example. So this graph shows the potential energy Ux of a particle as a function of its position x. Identify all points of equilibrium for this particle. So this is Ux versus x, basically shows the force acting on the particle is a conservative force. So we have the relationship between force and U. So force equals the negative of the slope. The points of equilibrium means the points of force equals to 0. That means the points of slope equals to 0. There are 2 points with slope equals to 0. One is at x equals to 2, the other one is at x equals to 5. So again, at equilibrium, force equals to 0, and force is negative du dx. That means force equals to slope. That means slope equals to 0. The 2 points with slope equals to 0, again, x equals to 2 meters and x equals to 5 meters. Suppose the particle has a constant total energy of 4 joules, as shown in the diagram, right over here, this line. Determine the kinetic energy of the particle at a following position, at x equals to 2 meters and at x equals to 4 meters. We know total energy equals to 4, that means kinetic energy plus potential energy has to be equals to 4 joules. So kinetic energy we don't know, but we know the potential energy is 1. So k plus 1 equals to 4, that gives us k at x equals to 2 has to be 3. Similarly, k at x equals to 4 has to be 1 because at that point the potential energy is 3. So at x equals to 2, E total equals to 4. So 4 equals 1 plus k give us k equals to 3. E total equals to 4. 4 equals to 3 joules. That is potential energy at x equals to 4 plus k. So that gives us k equals to 1 joule. Question. Can a particle reach position at x equals to 0.5 meters? Explain. So we know the total energy has to be 4 joules. So let's take a look what's going on at x equals to 0.5. When x equals to 0.5, we know its potential energy equals to 6 joules. So it's not possible because the total 6 joules is more than the total energy. The answer is no, because the E total is less than potential energy at 0.5 meters. Next question says, can a particle reach position at x equals to 5 meters? Well, at x equals to 5 meters, potential energy is less than the total energy, so that is possible. On the grid below, carefully draw a graph of conservative force acting on the particle as a function of x, for x less than 7 and greater than 0 meters. To find force, we use the relationship conservative force is negative of the slope. So to find the force, basically we have to find the slope, then we negate its slope. To find a force between 0 to 2 meters, we find the slope. In this case, the slope is negative 4. Therefore, the force is positive 4 between 0 to almost 2. At x equals to 2, we already know force equals to 0. So there's a point right here. Next one, between 2 and 5, the slope in the Ux graph is positive 1. That gives us the force has to be negative 1 because, again, force is negative of slope. From a little bit over 2 to a little bit less than 5. So again, at x equals to 5, the force should be 0 over here. From 5 to 7, the slope is negative 2. That gives us the force, conservative force, should be positive 2. So a little bit over 5 to 7 should be positive 2. Next one, we simply connect the points with a smooth line. Make sure your graph passes through 0 at x equals to 2 and at x equals to 5. Looks like something like that. Okay, that's it for today. Thanks for watching.